Dear students, see the next one from 9th standard, Force and Law of Motion chapter. This is NCERT textbook question, not example, not NCERT exercise question. This is inside the textbook, some blue color question is given after some theory, every theory. So this question is present in page number 127, question number 4 as a problem. Okay, theory question is also there, problem also there. So now I am going to solve the problem, question number 4. Okay, page number 127. See that this is also like a third question. They are based on law of conservation of linear momentum. But previous question they ask recoil velocity of the gun. But now we are going to find the velocity of one ball. So for example, let us take two objects. Okay. So object 1 and object 2. Okay. For your convenience, you can take two different masses objects. Okay. So maybe it's so this is the first object. Okay, otherwise diagram enough. Okay. So please listen. So two objects is there. Object 1, object 2. Object 1 mass is given, that is 100 gram. Okay. Its velocity 2 meter per second. Okay. The next rate. Okay. One more mass is traveling the same path. That mass somewhat big. So that is 200 gram. Comparing with this mass, this is doubled. Okay. Then this velocity is 1 meter per second. Comparing with this velocity, this is half. அப்போ மாஸ் இதோட அதிகமாக இருக்கு, பட் வெலாசிட்டி இப்படி இருக்கு, இதோட இது கம்மியாக இருக்கு. அப்போ என்ன ஆகும்? The same path is moving. Okay, this is 200 mass, this is 100 mass. 200 mass moving, what is the speed? Just 1 meter per second. But this 100 gram mass moving 2 meter per second. So what will happen? This 100 gram mass collide with 200 gram mass. So after collision, mass 1 different velocity, mass 2 different velocity, mass 1 velocity given, then mass 2 velocity what? That is the question. Very simple question, you know. ரெண்டு மாஸ் இருக்கு, ரெண்டும் ஸ்ட்ரெயிட் லைனா போகுது. First mass is impact collide with the second mass. Okay, its initial velocity is given before collision. This is at collision time. Okay, after the collision, mass 1 velocity is 1.67 meter per second. This velocity after collision 1.67 meter per second. That means what? Velocity is reduced. Then what about that another mass velocity? That is the question. Okay, so we are going to find the same method, that is the law of conservation of linear momentum. You know, the law of conservation of linear momentum, that is total momentum before collision equal to total momentum after the collision. Okay, so before collision momentum what? m1u1 plus m2u2. That is identity. m1u1 plus m2u2 is equal to after collision. After collision what happened? m1v1 plus m2v2. Okay, total momentum after collision m1v1 plus m2v2. Okay, then after that m1 value, this is m1. What is m1? 100 gram. You should convert it into kilogram because that is the SI unit. So 100 gram, how to convert into kilogram? This is multiple with 10 power minus 3. So 100 into 10 power minus 3 we can write as 0.1. So mass 1 is equal to 0.1. Next to U1. U1 is what? 2 kilogram. See the first. Okay, directly I read the concept. So 1 second. Okay, so first I explain the diagram. Now we can come to the question. Two object of masses 100 gram and 2 kilogram, 200 kilogram. Two object of mass 100 kilogram and 200 kilogram are moving along the same line, and the direction with the velocity of 2 meter per second and 1 meter per second. That means this is represent 2 meter per second, this is separate 1 meter per second respectively. So respectively சொல்லிட்டாங்க. So 100 gram தான் 2 meter per second, 200 gram தான் 1 meter per second. After that they collide Okay, and after the collision, the first object moves at the velocity of 1.67 meters per second. After collision, the first mass is moving with the velocity of 1.61 meters per second. So determine the velocity of the second object. That's all. So total momentum before collision equal to after collision. I can write as m1u1 plus m2u2 is equal to m1v1 plus m2v2. What about m1 value? 0.1 kilogram into u1 value 2 meter per second plus m2 value 200 kilogram. 200 gram, how to we can write? 0.2 kilogram. So 0.2 into u2 value. What about u2 value? 1. Then again equal to m1 v1. m1 is what? Same mass, that is 0.1. But velocity what? After collision velocity what? 1.67 plus m2. m2 what? 200 gram or 0.2 kilogram into v2. v2 we do know, that only we are going to calculate. Okay. So in this question we are going to calculate this v2, that is velocity of the second object after the collision. Okay. So please listen. So now 0.1 into 2, that is 0.2 plus 0.2 into 1, that is also 0.2 equal to 0.1 into 1.67, that is 0.167 plus 0.2 into v2. Okay. See the left side, 0.2 plus 0.2, that is we can write 0.4 equal to 0.167 plus 0.2 v2. Next, this 0.167 moving left side, it become minus sign. So already 0.4 is there, minus 0.67 equal to the remaining term right side 0.2 v2. Now we can subtract 0.4 minus 0.167, that is equal to 0.233. Okay, 4 minus 0.167, that is equal to 0.233 equal to 0.2 v2. So now we need v2 only. Therefore I can write v2 equal to, this 0.2 is multiplication here. If it is come this side, division. So 0.233 divided by 2. Okay, here down the denominator 0.2 is there. Here 0.233 is there. So better we should do for easy, our convenient, multiple and divide by 10. So மேல multiply 10 என்ன ஆகும்? 0.233 into 10, that is 2.33 divide by 0.2 into 10, that is equal to 2. So 2.33 divided by 2. Okay, so that is equal to, we can write 1.165. What is that? 2.33 divided by 2 I can write as 1.165 meter per second. So we found that velocity of the second object is 1.165 meter per second. Okay, but now the left side total momentum is what actually? 0.4. Like that, right side also if we multiply we can get 0.4 only, because total momentum is conserved. Okay, see that 0.1 into 2 plus 0.1 into 2, this is finally we can write 0.4, that is left side momentum. And like that right side momentum also 0.1 into 1.67 plus 0.2 into v2 what? 1.165. If you put the right side also, what you will get? What you will get? The same thing. 0.4 left side and right side you will get, because total momentum before collision equal to total momentum after collision. So after observation theory, okay, you should try, once again you try this 0.1 into 1.67 plus 0.2 into v2 value what? 1.165. So if you simplify right side, you can get 0.4. Okay students, so in this question, before collision, two different velocities given, then after collision, one of the velocity is given, then another velocity is asking. So by using law of conservation of linear momentum, it is possible. Okay, thank you.